we'll not be talking about more around how do you write those PyTorch models, but we'll focus on how you can use the managed services along with PyTorch models so that you can shorten your whole development cycle, right? And at the same time, if you have seen the my talk description, we'll also be focusing on more around distributed computing or distributed training of the models. Right? These days, the models are becoming large and large, right? And the training time being from hours now, it's we have seen models which have trained for months, right? And we don't want to have that pretty much every time. So which is where the distributed training paradigm comes in, and we'll talk about that and then see how you can train your PyTorch model in a distributed fashion and like integrate the managed services, right? So before that, just a primer on distributed training, what it is, or how it helps us. So because of this training time becoming large, because of the model size becoming larger and larger, it is desired that we break our training life cycle into in a distributed fashion so that we can reduce our training time drastically, right? And this also shortens our training time, increases our go to market, or how you want to scale up or experimentation, right? And you can achieve a results quicker. But with this, right, when you talk about, let's say you have you want to break your training into a distributed fashion, what you're doing was maybe you use some of the libraries and you made the code changes, right? But that's not it, right? You then start thinking about issues around how you manage infrastructure, fault tolerance, how do you optimize your accelerators so that you can get most out of the accelerators you have, right? Can be GPUs, TPUs, or anything else, right? Or you also have to since now you have a cluster where you are running distributed training, how do you make sure that the bandwidth within these nodes are efficient so that the whole your training process is very efficient. Again, I'll not talk much about Vertex AI, but this is the whole suite of managed services that helps you to focus or to build your machine learning models. There are a set of services around experiment, train, deploy. You can then use things around explainability, AI, or even feature store, so you can store your features and then do your model training, right? In this talk, we'll focus on some of these aspects where you can directly use them with PyTorch, such as training your model, exposing them, and then how can you write an end-to-end pipeline so that your model training iteration becomes faster. The first thing is when you come to train your model, right? It starts with pre-built containers. So we supply these pre-built containers where you can directly use them. And these images are available for CPU, GPUs, TPUs, or even works with all the NVIDIA drivers, right? To start with, it starts with this Docker container script, right? So here at the top, I have listed this Docker container, and then inside this, we'll put your, if you want to install any more dependencies, you can do that. And at last, you put your trainer, your configuration or your training script, and then start write this to invoke them, right? When you configure this Docker container, the next step, when you actually want to run this training container, it starts with this AI platform, that custom container training job, and here you can see I've listed a Docker container and where the container is stored, right? But this is not it, right? This works for a simple POC, or you just want to test your pipeline and see if everything works fine. The moment you want to start or scale up a training, which is where these configurations, this thing comes around, right? Whether you want to do a single node, single GPU training, where you can just list, I need an this machine type, this accelerator, and I want one, right? If you want to increase this even further, then you can say, I need 4 accelerators, or even or how many replicas you want, right? When you want a multi-node, multi-GPU setup. Focusing on this, right? So majorly we'll focus on this part, multi-node, multi-GPU setup, and see how that works out. So when you talk about multi-node, multi-GPU, right? So you have multiple nodes in a cluster, and each node is doing separate work. And if you have to look at it, so right, so if you have, you can configure how many GPUs you want, how many accelerators you want, and at what sizes you want them, and with this multi-node setup, you also want a way to now think about this, right? Your model is broken up, your data is split up, and it is running in different accelerators. And now, how do you combine these weights from all these accelerators, combine them together, and then even distribute them back, right? So that the next iteration can start, and your all your accelerators have the same snapshot, right? So for that, if you look at here, right? So if you, for example, the worker pool 0, which is called your main node, so which is the master head, which schedules, which makes sure that all, which manages the training across all your clusters. Second is the worker pool 2 is the secondary replicas of workers, where these are your actual workhorses where actually your model training runs. Second is your worker pool 3, which is also your reduction server. So here, what happens is, when across your workers, right, your models are training in different data splits. These weights can be combined, are combined into the reduction server, and then they're sent back to all your uh, uh, worker nodes, right? And fourth are the evaluators, or you can also configure them the way you want. It can be, or it can also run your additional nodes so that you can uh, run your training there. Yeah. So this, for this, again, right, it's again pretty much straightforward. So it starts with you mentioning how many replica count you want, and so these replicas are, right, how many node groups you want, right? You want only one node group, or you want to have a reduction server, you want to have like master and a couple of worker nodes, right? Then with you have to basically then configure this command. So here you can say, right, how many nodes you want, how many like processing nodes per node group, then which code to run, like the script that you have, and also the endpoint, right, from where it is exposed. And then you can run, again, you have to configure this custom training parameter job. Here you will pass on your container URI and the command that you have run, and when you call job.run, here you can again specify, right, like how many replicas and what kind of machine that you want to run this job for. Now that if I go back here, right, so think about this, right? So you have your Docker containers created where you have your trainer script. Then you configured it to run on a multi-node, multi-GPU setup where you have configured, how many replicas I want, what should be my node setup, how many clusters I want, and so on, so right. Once you have that, then the things gets, the next issue is, now that you have all your worker nodes and your training is running across this, how will you make sure that your performance is optimal, right? You are getting the most out of the infrastructure that you currently have. Uh, so that is where Vertex AI reduction server comes in, right? So what I told you about, right? So you have these training running in different nodes, and what this reduction server is it just takes a snapshot of all the weights across your nodes, runs, brings them down into a separate machine, uh, does an aggregation of them, sends back, right? So here you can actually use a low, like a smaller machine instead of having a large machine to do only that part of the job. So your main workhorses where a large machines are, these are running your actual training job, and only this like aggregation is done on a smaller machine, and like which is done in optimal way, right? And this and I think this supports everything, or like reduction server. This supports anything that is written using NVIDIA NCCL library, and basically this is what, right. So your workers are running different training jobs. It broadcasts, and your reducer is running on a smaller machine where it does that and sends them back to all your worker nodes. So this is when you configure the job.run to actually execute your job. This is where you specify that. So you again add this chunk of like parameter reduction server replicas you want. What kind of machine that you want here? So maybe in your main machine where you have a GPU which is running the training, in your reduction server you can just have a machine with high CPUs, right, which only does the aggregation part, and then you pass on the reduction server logic again in a Docker as container, and it will orchestrate it. The Vertex AI will orchestrate that way, and so this is just an example or a study that was done to see, right, and compare NCCL all reduced. Yeah, okay. NCCL all reduced versus reduction server, and what you can see here is with reduction server, PyTorch distributed training throughput is around 80%, and overall training time gets reduced by almost 45%. Right. So this, if you can go to this blog, you can actually see how this was done, and actually look at the specifics of this experiment. So now you have your models running or training on a data split across your cluster, where you have also taken care of the like how do you aggregate all the weights. The next thing is hyperparameter tuning, right? So in here Visor helps you to now take your job which is running in a distributed fashion to now like run hyperparameter job on top of this, right? So what you do is your same custom job specification that you have configured earlier uh, here. The same thing what you do now is you prepare a file based on configs, and for each iteration then you report the metrics into and in like via hypertune, right? And then what Visor does is based on these metrics it suggests what should be your next parameter for next run, so that and this loop continues till you achieve like on what metric you are actually optimizing a model for. And once that is achieved, your model actually gets, for each of the trial, gets stored in a cloud storage bucket with the logs, right? So now you can see, okay, for this run with this hyperparameter, this was my experiment results, and based on that you can decide the best model, or you can select any intermediate step if you want to. And the same thing here. So what you have to do is once you specify a custom job, you can just create another hyperparameter training job. Here you say, right, what metric specification you want, how many number of trials, how many parallel experiments can run together, and then run the hyperparameter job, right? So and based on this flow, this all the experiments will be created, and your results will be exposed at the end. The last is inference of these models. So now let's say, right, you have a model which is trained, which is tuned, right, and now you have that model, right. When it comes to expose, you have your PyTorch model actually stored in a cloud storage bucket where your model weights are stored. What you use then is model archiver to package all the models into single model archive, and then create a doc. Again, the same container that you use for training can be used here. You write your own inference logic in that container, and then use since your model now is archived, this model can users have to register that model in Vertex AI model registry, and then expose using this model using the container via endpoints. So here what you do is once you have trained your model, you just do a model dot upload, and the exact location here where your model is stored, the serving container image which you have created, display name, and this will then be uploaded and registered into model registry. Once the model is registered, then you can just do now, since model registry has your container, your model attributes, and all the metadata for it, you can then take this and just call this constructor AI platform dot endpoint dot create, and just give it a name, and this endpoint will be created. And once that is done, you can just, now your endpoint is created, but it's not even deployed. It's just a placeholder for you which is created. You can use it for just checking if your configurations are correct, right? Once that is done, you can then call model.deploy, and here you can pass on the endpoint that you have created, the model endpoint name, the machine, what kind of machine you want here, and also traffic percentage, right? If you want to do a like candy deployment, that you already have a model in deployment, right? So what this will create is maybe your if you configure in such a way that your 10% traffic comes to this new model, but your rest of traffic goes to the old model, right? So you can configure it right here. Yeah. Now we have talked about each of the steps, right from the training step, second uh, tuning the model, third is exposing the model, right? Now then you have all these steps. how do you combine everything together so that you can do it in a repeated manner, right? You don't want to go to each steps every time you have to train a model, deploy instance, right? So which is where your Vertex AI pipeline comes in, right? So think of it as your, if you have worked on Airflow, right? Your Airflow acyclic jobs, and each step here is a stage of your uh, model life cycle, right? And every step you can use a container. So let's say you can have a separate container that runs on a smaller machine just for the data aggregation job. The same, once the data aggregation job complete, you pass on the same data to a larger machine so that the models get trained, right? So that you are not occupying a large machine for the entire life cycle. You just break your job, break your whole pipeline into smaller chunks, and each chunks using that, having them in a pipeline also helps you to start your training from any given point. Let's say your data is prepared, you don't want to have the same thing running every time you run the pipeline, right? So you can, uh, yeah. So let's say you created this pipeline, and this is the flow, right? You start with building the container, then creating a custom job. Third is once the job is ready, you can just go and evaluate, and based on that create an endpoint and deploy the model, right? So now you don't have to create the like container every time you run, right? So you can just start your training right from just starting the training job and go downstream, right? Let's say in and based on certain checks, maybe your job failed in between, right? So next time you want to fix and run, you can again start right from where you left last time, and don't not run the same pipeline again. And all the steps, right, all your steps in your whole life cycle gets integrated into one pipeline, right? So right from data extraction, validation, data preparation to model deploy, right? And at every step, at every phase, you have different managed service that helps you do that part of the job in a more efficient way. Yeah, I think that was it. So these are all the links that I have listed across my presentation. You just scan the QR code, and it will take you to all of these different documentation blogs that you can go and read them in a more detail. I think that was it. Thank you.